Let's go ahead and practice solving some equations where we have to simplify each of the expressions on the left side and the right side of the equation first. So let's see, in questions 1 through 4, we're going to go ahead and solve these equations following each of the justifications provided. So for the first one, let's go ahead and write the original equation down. So let's just go ahead and copy down. We have 4x plus 2x, take away 8x, and that's equal to negative 5 minus 9. Okay, so it says combine like terms on each side of the equation. So I'm going to use this purple color for the left side of the equation. 4x plus 2x minus 8x, they're all like terms with each other, so we can combine those coefficients. So let's see, 4 plus 2 is 6. 6 minus 8 is going to be negative 2. So we can go ahead and say this is going to be negative 2x along the left side of this equation. So we just simplify the left side. What about the expression on the right side? I'm going to go ahead and use this green color. For the right side of the expression, we have this subtraction of two constant terms. Negative 5 minus 9 is going to be negative 14. So I'm going to go ahead and write that. And so that's going to be the simplified version of the right side of the equation, or that right expression. Then it says go ahead and apply the division property of equality. So if we go ahead and do that, let's see, what would we divide both sides by? Well, the coefficient of x is now negative 2. If we want to get x alone or have a 1 in front of it, we should divide by negative 2, right? So let's go ahead and take both sides of the equation, apply the division property of equality, and divide both sides by negative 2. All right. Technically, it'd probably be good to put some parentheses around this negative 2 just because we have an operation there. So let's go ahead and actually put that here so it's a little bit more organized. Okay. So what are we going to get if we do that? Well, keep in mind that this part on the left side, this is negative 2x over 1. Divided by negative 2 is really times 1 over negative 2, right? So you can see here that these are reciprocals or multiplicative inverses of each other. So we're going to get 1x on the left side. And on the right side, let's go ahead and just evaluate what this is going to be. Negative 14 divided by negative 2 is positive 7. And then finally, going ahead and using the identity property of multiplication, 1 times x is just x. So we can drop the 1 and say that x is equal to 7. Okay. Let's try another one here. Let's go ahead and start by writing the original expression equation. So there's two expressions. On the left, we have 8 minus 44. And on the right, we have 2 times the quantity of this 4x plus 12x. Now, if we're going to go ahead and combine some like terms here and simplify this 8 minus 44, that should be negative 36 along the left side of the equation. What about the right side? Well, the right side, it says go ahead and combine like terms. So let's go ahead and do that. If we combine these like terms of 4x plus 12x, that's going to be 16x, right? So on the right side, if we combine like terms, it's going to be 2 times, and we're going to get this 16x on the inside of the parentheses. Now, could you have distributed this 2 to both of these terms? Yeah, you could have, but I'm just following the justifications here. So there's more than one way to kind of go about it. So you could distribute, then combine the like terms after that. It says apply the associative property of multiplication on the right side. So what does that mean? Well, right now 16 and x are multiplied together. If we apply the associative property, we can move the parentheses with the grouping symbol over here to simplify this. So we're going to get negative 36 is going to be equal to 2 times 16. If you apply the associative property, it moves it over, and then you can evaluate that to make 32x here. Next, let's go ahead and use the division property of equality. The coefficient of x is 32, so hopefully it makes sense to divide both sides by 32. So let's take the negative 36 on the left side. Let's divide it by 32. And on the right side, let's also take the 32x, and let's divide that by 32. Okay, so on the left side here, if we have negative 36 over 32, you could do the long division, but you can also think of negative 36 over 32 as a fraction like this. You can divide top and bottom both by 4. So if you do that, if you divide by 4, you're going to end up with negative 9 over 8. And so you can leave it as a fraction or a mixed number. So that's going to be negative 1 and 1/8. So I'm going to write it as a mixed number, negative 1 and 1/8. That's going to be equal to, and on the other side, this 32x divided by 32, that's 32x over 1, and divided by 32 is the same thing as multiplying by 1 over 32, so you can see these are multiplicative inverses of each other, or reciprocals of each other, right? So if that's the case, the 32 over 1 times 1 over 32 just becomes 1x, and then using the identity property of multiplication, 1 times x is just going to be x, so we can say x is equal to negative 1 and 1/8. If you wanted to write this division problem out, you would have gotten a decimal, and if you did that, You could also write -1 1/8 as a decimal, and you should end up with -1.125. That's the same thing as 1 1/8. All right. For number 3, let's go ahead and try another one here. So on the left side, we have -4 minus 18 plus 1 is equal to, and you don't have to write the 1 here, but I'm going to write it just so we don't accidentally miss it, -1n minus 4n plus 2n, right? So we're going to have this original expression on each side. And if we go ahead and apply some of our properties where we can go ahead and simplify a bit, we can combine all these like terms, these constants on the left side. So -4 minus 18, that's -4 plus -18, that's -22, plus 1, that's going to be -21 on the left side here, okay? What about on the right side? Well, the right side of the equation looks like we have a bunch of like terms as well. We have all these variable terms with the same variable. So let's see, we can combine all these ones. So -1n plus -4n is -5n, -5n plus 2n is -3n. -1n minus 4n is -5n. -5n plus 2n is going to be -3n. So I'm going to go ahead and combine everything on the right side to make -3n. Okay, so it's a little bit more simplified. Let's go ahead and now apply the division property of equality. Let's take both sides of this equation, and let's go ahead and divide by the coefficient of n, which is going to be -3. All right, so let's go ahead and take that and take the -3n over here. And let's also divide this by -3. All right, on the left side, we can go ahead and just evaluate a negative divided by negative is a positive, so we're going to get +7. And on the right side, hopefully this is getting a little bit more fluent for you, but -3n is -3n over 1. Divided by -3 is the same thing as times -1 over 3. Again, these are multiplicative inverses of each other. Ignore the n for here for a moment. So you can kind of, I guess, use the commutative property and change the order of multiplication. But the -1 over 3 times -3 over 1 just gets you 1. So we have 1n. And then using the identity property of multiplication, we can say n equals 7. All right, cool. Let's try one more of these types of problems. We'll start by writing the original equation down. We have -24 plus 13 minus 1 is equal to, and then we have n, which is 1n, and then -5 minus 2 plus 8. Okay, let's go ahead and clean up the left side, combine some like terms here. -24 plus 13 is going to be -11. -11 minus 1 is going to be -12. So if we combine all the constants on the left side, we just get -12. And on the right side, we can go ahead and combine some like terms here. So the only ones we can combine are these 3 constants. So don't combine this 1n with the other non-like terms here. So -5 minus 2 is -7. -7 plus 8 is going to be 1. So we really have 1n, and then what do we have here? Plus 1? Yeah, plus 1. Okay, let's see here. We can drop the 1 here, so we can feel free to do that whenever. So I'm actually just going to do that now. We don't really need to write it because we like having that 1 there, right? And so what we can do next, though, is it says to go ahead and use the subtraction property of equality. So what are we going to subtract? Well, we're going to subtract 1, I think, right? So let's take the -12 on the left side. Let's take away 1. And on the right side, let's have this n plus 1. But then let's go ahead and also take away 1. On the left side, -12 minus 1 is going to be -13. And on the right side here, we have this 1 minus 1, or 1 plus -1. That's going to be 0, right? And that's using the additive inverse property. And then using the identity property of addition, we can go ahead and drop that 0 and say n is equal to -13. All right, let's go ahead and try a few more problems here. This time you're not going to have the justifications, but we want to go ahead and see if we can still think through the logic properly here, okay? We need to make sure we simplify each of the following equations on both sides. Use one of those property of equalities, as well as the inverse property, whether it's multiplicative or additive, and then we use an identity property. And let's go ahead and show any calculations we need to show, but we don't have to worry about checking right now, but you could if you ever wanted to. So let's just look at the left side first. I'm going to highlight this part over here. Let's just combine the constant terms here. So -5 and -5 is -10. 18 and -10 is just 8. So we're going to have x plus 8 on the left side of the equation. And I'm just going to highlight the same color to keep it nice and organized. And on the right side here, we have -38 minus 42. That's the same thing as -38 plus -42, which I think is going to be -80. All right, cool. So hopefully this equation now is going to be a one-step equation. Let's go ahead and after we simplified, let's go ahead and use one of those properties of equality. So I think we're going to go ahead and use the subtraction property of equality. Let's go ahead and take away 8 from both sides. If we go ahead and do that, we're going to end up with x. If we do the additive inverse property, we're going to get 0. And then negative 80 minus 8 is going to be negative 88. And then if you use the identity property of addition, we can drop the 0 and say x is equal to negative 88. Okay. Now I recommend if you're still like working on getting better at knowing all the properties and such, practice saying it out loud as you do it to make sure you understand why we're allowed to do what we're doing in each step. I think it's going to help you form a very strong foundation for understanding how equations and math works like this. Okay. Cool. Let's try another one. Let's look at number 6. For number 6, let's see, the left side here, we have negative 14 plus 23. Let's just go ahead and add those constant terms together. I think it's the same thing as 23 minus 14, which is going to be positive 9. Okay, so the left side is pretty simple there. And on the right side, what are we going to have? So let's just look at this. And we have some constant terms to combine here. Leave the y alone. So we have the y here. And then let's see, negative 13 minus 28, that's negative 41. Negative 41 minus 4 is negative 45. Okay, so I believe that would be the simplified version of the right side here. Next, if we use the addition property of equality, we can go ahead and add 45 to both sides of this equation. If we go ahead and do that, then on the left side, 9 plus 45 is going to be 54. And on the right side, negative 45 plus 45, that's the additive inverse property. That's going to get us 0. And then afterwards, you can use the identity property of addition and drop the 0 and say that y is going to be equal to 54. That would be our solution. All right, let's check out number 7. For number 7, let's take a look at the left side first. We have negative 5n minus 1n minus another 1n. So that's going to be a total of what? I think it's minus 7n because there's these negative 1s in front of each of those minus n's, right? On the right side of the equation, let's take a look here. We have a bunch of constant terms here. So negative 5 minus 12 is negative 17. Negative 17 minus 11 is going to be negative 28. Okay, that would be our right side. Cool. Now that we simplified the left side, simplified the right side, let's go ahead and use a property of equality. Let's go ahead and divide both sides of the equation by negative 7 using the division property of equality. On the left side here, this is negative 7n over 1, really, and then it's divided by negative 7, so it's really times negative 1 over 7 if you think about it. So you can see that these are multiplicative inverses or reciprocals. If you multiply those, we should always get 1. And on the right side, negative 28 divided by negative 7 is going to be positive 4. Then using the identity property of multiplication, n equals positive 4. So you can go ahead and write that as our final solution. All right, let's check out another practice problem here. For number 8, on the left side here, we can go ahead and look at all these constant terms here. Negative 14 minus 13 is negative 27. Negative 27 plus 7 is going to be negative 20. So that's going to be on the left side of this equation. What about the right side? On the right side, we have a bunch of variable terms. It looks like they're all like terms with each other. So negative 4n plus 7n is going to be 3n. 3n plus 2n is going to be 5n. So you can see that if you simplify both sides, we get a one-step equation, just like all the other problems we've done here. Which property of equality should we use? Well, we'd like our coefficient to be 1, so in order to do that, let's divide both sides by 5. On the left side, negative 20 divided by 5 is going to be negative 4. And on the right side, 5n divided by 5, or 5 over 1 times 1 over 5 is just going to be 1, so it's going to be 1n. And then using the identity property of multiplication, we can say n equals negative 4. Here's number 9. In number 9, we have this negative 2v minus 1v plus an 8v. Now, negative 2v minus a v here is going to be negative 3v. Negative 3v plus 8v is going to be 5v. All right, so that's going to be the left side here. Now, what about the right side? On the right side, we have 3 constant terms here. So let's go ahead and combine those. So negative 4 plus 3 is going to be negative 1. Negative 1 minus 39 is going to be negative 40. So the right side here combines all together and simplifies to just being negative 40. And let's go ahead. We have a one-step equation here. What property of equality should we use? I think we should go ahead and use the division property of equality and divide both sides by 5 here. Okay, so 5v divided by 5 is just going to be 1v using the multiplicative inverse property. And then on the right side here, negative 40 divided by 5 is going to be negative 8. Now using the identity property of multiplication, we can drop that 1 essentially and say v equals negative 8. All right, cool. That would be the solution to this equation. All right, here's one final example. For number 10, let's go ahead and see here on the left side of the equation, we see we have this negative 2 times the quantity of this 5e minus this 8e. Now you could distribute first if you wanted to, or you could also combine like terms first. Now earlier in the first 5 problems, I think we combined like terms first. So I'm going to show you if in case you wanted to try this as well, you can go ahead and distribute just to see a different way of doing this. If you choose to distribute first, we're going to get negative 10e, and then it's going to be a negative 2 times a negative 8e, so it's going to be a positive 16e. Okay, that's going to be the left side here. But I think we can also combine those like terms, right, and get positive 6e if you combine those ones right here. Okay, if you chose to subtract these first, you would get negative 3e, and then you hopefully can see negative 3e times negative 2 does end up with positive 6e. So you have to do 2 steps either way, but hopefully that makes sense that either one would work depending on your preference. Okay. On the right side, we have all these constant terms here. So a negative 31 and a negative 5 make negative 36. Negative 36 plus 48 is going to be 12. So we go ahead and say this is going to be 12. And I guess we can just copy that down here and just write it equal to 12, just to keep it nice and clear. And now we have a one-step equation. Hopefully it makes sense. We should use the division property of equality and divide both sides by 6. If we do that, we can use the multiplicative inverse property and say 6 times 1 6 is just going to be 1e, and 12 divided by 6 is going to be 2. And then 1e is really just e using the identity property of multiplication, and we know e has to equal 2 for this problem. All right, so there you have 10 different practice problems dealing with solving some equations where we just had to go ahead and simplify, combine some like terms and such on the left side of the equation, as well as taking care of the right side of the equation. Once we cleaned up both sides independently, then we went ahead and used a property of equality, then one of the inverse properties, whether we used a multiplicative inverse or the additive inverse, whether we were getting 1 or 0. Then afterwards, we used the identity property, either the multiplication or our addition one, where we got 0 or 1. To get each of our final solutions. So hopefully you found the video helpful. If you did, please consider giving the video a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep with the great work that you're already doing.